Hello Year 10, today is our second lesson on vectors. What we are going to be doing today is looking at how we can add and subtract two column vectors, or maybe even three, and how we can represent that with a diagram. So I hope you've managed to print this sheet out. If you've not been able to, do not worry, because you can just draw some of the diagrams into your book and you can just write some of the main information down. So just as a little reminder from the previous lesson, I've drawn in a vector A, I've drawn in a vector B, and I'm just going to represent these two vectors using the column vector notation. So I'll just drop in a little A with an underscore there, an underline, and a B with an underline there. So I can see that vector A is 3 to the right and 4 up. So remember, we would write that one as 3, 4. And for B, I have gone 2 to the right and 2 down. Remember, we can tell that from the direction of the arrow. So 2 to the right and 2 down. And that is 2, negative 2. Now, let's suppose that I put these two vectors together. In other words, I went along A, and immediately afterwards I went along B, which would be A add B, as drawn here. And this is where I want you to start thinking about vectors as a little bit like being on a map and you going from one place to another place, a little bit like translation. So if I did A to B, I would start here, go along A, then go along B, and end up there. But overall, as a translation or as a vector, I have moved from this starting point to this finish point. Okay, and this is called the resultant of A plus B. And if we look at this vector and represent it as a column vector, this blue dashed line, you will see that I have gone along 5 to the right and up 2. Now, what's really interesting is when you look at the answer to this and look back at these two vectors here. Because if you look at the x components, as in the top numbers of the vector, 3 add 2 is 5. And if I look at the y components, 4 add negative 2, so that's like 4 subtract 2 equals 2. So we can just add the x components and the y components to get the resultant vector. And what we're going to see in a moment is this also works for subtraction. So here are two more similar questions. We're going to do another addition first. So I've got C as 6, negative 4. So you can see I've represented C by 6 to the right and 4 down. And we're going to add D, which is 2, 5. And you can see for D, I've gone across to the right 2 and up 5. And I've drawn in my resultant here. Okay, well, let's do the addition of the vectors first and then see if the diagram agrees. So, adding the x components, 6 plus 2 is 8. And adding the y components, minus 4 plus 5 is 1. So I'm saying C add D equals 8, 1. Let's see if that's true on the diagram. So this blue vector is 8 along and 1 up. That is 8, 1. So we've now seen an addition done twice. Subtraction can be a little bit trickier. Okay? And the reason being, when you subtract a vector, it is like doing the same vector but in the opposite direction. So what I mean by that is if this was, say, vector A, then negative A would be the same vector but in the opposite direction. And you'll see how this works in a diagram in a moment. So I've got E as negative 3, 2. And I know how to draw negative 3, 2. So I've started here and I've gone negative 3, so 3 to the left, and 2 up. Now when it comes to drawing the vector 6, 2, because I am subtracting it, I have drawn 6, 2 exactly the opposite of what I should have drawn. So instead of doing 6 right, I have done 6 to the left. Instead of doing 2 up, I've done 2 down. So that would represent negative f. And there's another way of checking, because if I go back this way, that is 6, 2. So going that way would be plus f. But I wanted to do E to my in-between point and then negative f from that point there. So let's try subtracting these components and comparing it to the diagram. Negative 3 take away 6 is negative 9. And 2 take away 2 is 0. Does that agree with my diagram and the resultant? Well, I've got a horizontal line, so that definitely means the y change is 0. And 4, 5, 6, 7, 8, 9. So yes, it is negative 9 from E to F. I could even label these as C plus D. And I could label this one, the resultant, as E take away F. Now sometimes you need to be a little bit careful when you're subtracting a column vector, because you might end up subtracting a negative number, and then the usual rules of maths kick in, that if you are subtracting negative numbers, that is equivalent to adding. Now there's going to be one other type of question you see in the exercise that I've selected for you today, and that's something that I'm just going to refer to as a simple equation. And the reason why I'm going to refer to them as equations is because I want you to think of these just like equations. We have seen in the addition and the subtraction, you can just look at the x components and the y components separately. And that's exactly what you have to do in something like this with some unknowns. If I just look at the x components, I can see that x plus negative 3, well, that's the same as subtracting 3, equals 6. And I have got a super easy linear equation to solve. What is x if x take away 3 is 6? Well, x has to equal 9. Similarly, if I look at the y components, I have got 8 plus y equals 6. And the only value of y that makes that work is negative 2. So y is negative 2. So that's it for today from me. Do jump back onto the instruction sheet so you know what you're doing next, and have a look at the exercise, and all of the answers are there for you. But for the time being, that's me signing out. See you later. Goodbye.